Hi, good evening. Are you able to hear my voice?
Yes, sir.
Okay, thanks. So last week there was no class. I had intimated the PMRF support team, I mean the NPTEL support team last week itself.
Yes,
So
sir.
so I was out of station due to some conference and that's why I wasn't available to take class.
Okay, sir. Actually, I joined that session, but there was nothing.
Oh, okay. So I had intimated to the support team, NPTEL support team that I wouldn't be able to join. I just intimated a few hours before the session start. Probably they didn't find
Okay.
time to update. Okay, so we'll continue on. Um,
Yes.
so today is for week 8, and we will be having one compensation class on Saturday.
Okay,
Probably,
sir.
probably you will be getting a message also. I will intimate the exact date to them. And
Okay.
so we have one class probably this Saturday or Sunday. I will intimate, and next class will be on next Tuesday. And after that, there is also a extra session wherein we will summarize the entire course. That will
Yes.
again fall on a Saturday or Sunday, and then we will have the usual Tuesday sessions.
Okay, sir.
Okay. So is my screen visible?
Yes, sir. Visible.
Okay, great. So let's start then. So this would obviously correspond to week 9 because ideally this should have been week 10, but because of last class getting missed out, we will start with week 9.
Okay, sir.
So this week we are having a few questions on magnetics. So we will
Yes,
just
sir.
see them one by one. Okay, yeah. Um, Let me just open the questions and yeah. So the first question is the energy stored in a the energy stored in a parallel plate capacitor is 40 millijoules. The potential difference between the plates is 50 kilovolts. If the separation between the plates is 5 mm, determine the surface area of each plate. Okay, so this is basically a class 12 question in
Yes.
meter square. Okay, so what they have given is they have given you the energy stored. Energy is 40 millijoules and potential difference, let's call it V, So potential difference is 50 kilovolts. 50 kilovolts or 50 raised to 10 power 3. Right. And then the separation between the plates, which is D. Right. So your D has been given as 5 mm. Let's convert it to meters. So 5 into 10 power minus 3 meters or 0.005 meters. Okay.
Yes, sir.
So the question is find out the value for A. Right. So they have not given anything related to the dielectric. So we will assume that the nu r is 1 or the epsilon r is 1. So first of all, you know that E is what? E is basically half CV square, correct? So
Yes.
E is half CV square. So which means that you have half into C is what? C is epsilon naught, epsilon r, A by D, right? In a parallel plate capacitor, correct?
Yes.
Epsilon A by D. So this is basically your E. So you kind of rearrange the terms and you end up with A is equal to what? A is equal to E into 2D divided by epsilon naught, epsilon r, and then you have your V square. Correct?
Yes, sir.
So, yeah, so over here you just need to substitute the terms, you end up with the answer, right? So,
Yes.
A would be basically 40 into 10 power 3 into 2 into D is 5 mm. So 5 into 10 power minus 3 divided by epsilon. What is the value for epsilon naught? It is
8.8.
sorry, I just got disconnected. So
Yes, sir. Because of network issue.
probably just a sec. I'll just yeah. So I hope it is now visible.
Yes, sir.
Oh, you know that your epsilon value is going to be 8.854.
8.854 into 10 raised to power minus 12.
Correct. 8.854 into 10 power minus 12. Epsilon r, they haven't given anything. So let's assume it to be 1. And V is basically 50 kilovolt. So 50 into 10 power 3. And it is squared. Right. So basically,
Yes.
this is the answer. Um, so if you have calculator, you can try to calculate. I will also calculate this. Just
Yes, sir. 14.
assume what. um,
0.0181.
Correct. Correct. So you get 0.018, yeah, 0.0181. So
Yes.
That is your answer in meter square, 0.0181 meter square. Correct. Oh. Yeah, so 0.0181 meter square. Okay. Fine.
Yes, sir.
So let me just cut it and okay. So we'll move ahead with the next question. So the next question is so the next question is a little bit different. It says the upper plate of a parallel plate capacitor is held stationary. So you hold the upper plate stationary, fixed at one location, while the lower plate is free to move. The surface area of each plate is 20 centimeters square, and the separation is 5 mm. Determine the mass of an object suspended from the lower plate that keeps it stationary when the potential difference is 25 kV. What is the energy stored in the magnetic field? In microjoules. Okay, so let's try to understand the question. The question is that the upper plate of a parallel plate capacitor is still stationary, which means that if you have so you have the upper plate over here, just a two-dimensional view that I'm drawing. So the upper plate over here is held stationary. Okay.
Yes, sir.
Okay. And the lower plate is free to move. So you have the lower plate as well, and it is kind of free to move. Right. The surface area for each plate has been given as 20 centimeters. Okay, so each plate has a surface area of 20 centimeters square. And the separation is also given to be 5 mm. So the question is, determine the mass of an object suspended from the lower plate that keeps it stationary when the potential difference between the two plates is 5 kV. So they have also given the potential difference between these two, that is 5 kV. So what should be the mass of the object that you will suspend from here? So let's say there is an object suspended from here, it has a mass m. So what should be the mass such that the distance is 5 mm and the potential difference is 5 kV? That is one. And next part is, what is the energy stored in the magnetic field in such a scenario? Okay.
Yes, sir.
In- Okay. So let's try to solve this. Let me take a new slide. Okay. So probably the question is not magnetic field, it should have been electric field. There is a slight mistake over here. Yeah. So the question should be obviously electric field. Okay. So do you need time to note down the question, or like can I go to the next slide?
Okay, so you can go to the next slide. I have written.
Okay, fine. Um, okay. So the question, so now we have to find out what is the mass, right?
Yes, sir.
Okay. So the point is, they have given that mass is suspended, right? So mass is suspended, which means that it has been suspended against gravity. Okay.
Yes, sir.
So based on our basic Newton laws, we know that F is equal to m into g, right? Where g is 9.8 meter per
9 point.
second square. Therefore, m is basically what? M is basically F by g. Okay.
Yes, sir.
And under equilibrium, you know that your forces are going to get balanced, which means that your force due to your electrostatic or your electrostatic force is going to be the same as the force that is exerted by the gravity, right? So your Fg and your F electrostatic are going to be the same. So find out what is F and you can find out what is M eventually, right?
Yes, sir.
Hmm, fine. So first of all, we have to find out what is F, right? So
Yes, sir.
for that, what we do is, okay. So one basic thing that we know, energy storage in an electric field, right? So energy stored in an electric field is basically what? You know, it
Half
is
CV.
half CV square. Okay, basic. And they
Yes.
have also given that it's a parallel plate capacitor, which means that C is equal to epsilon A by D, where epsilon is equal to epsilon naught epsilon R. Okay.
Yes.
Therefore, your energy is going to be what? Energy in an electric field is going to be half into epsilon A by D into V square. This is your energy. Okay.
Yes.
Now, what is the force? This is the point that we have to take note of, right? How do you link energy with force? Electrostatic force, right? What is the electrostatic force? Fe. See, how do you link electrostatic force or how do you link force with energy, right? So basic
Between
physical
the
equation.
plates, between the plates
Sorry?
of plate capacitor.
Huh. So what does the force try to do? Force tries to kind of reduce the separation, right? So force tries to, it tries to bring the plates together. Okay. So what you would get is your electrostatic force is basically negative um, d energy by dd, correct?
Yes, sir.
So or let me use, instead of D, I will use, let's say, dou. Okay.
Yes, sir.
Differential of your energy with respect to the distance, that is your force, right? Differential of energy with respect to the distance. Now you have a D term over here. We can just go ahead and differentiate it with respect to D, and you will be getting what is the force out of that. Okay.
Yes, sir.
This is basically what this is your, just if I consider the magnitude. Okay. Anyway, this negative term is going to vanish, so that's not a problem. So everything else is a constant, right? So half into, you have got epsilon A into V square, and then you have got dou by uh, dd of 1 by d, correct?
Yes, sir.
So that is going to be minus half into epsilon A V square into, so what is d inverse differential? Minus 1 into 1 by
1
d
by D.
square. Right? So your negative and negative are going to get cancelled. So therefore you will be getting half into epsilon A by d square into v square. This is your electrostatic force. And
Yes,
you
sir.
know that under equilibrium, your electrostatic force and your gravitational force are going to be the same, because they have told that in the question itself, at what force is the, are the plates going to be at rest? Are they going to be at equilibrium? Therefore, your electrostatic force and gravitational force are going to be the same. Therefore, your Fe is basically just a differential of your energy with respect to the distance. Okay, differential of energy with respect to distance. So you should remember, or you should kind of note, what is the relation between your force and energy.
Yes, sir.
Force and energy, how are they related, right? So turns
Yes.
out that force is basically a differential with respect to the distance. Okay, differential of energy with respect to the distance. Okay, so now we have got what is electrostatic force, that is half epsilon A by d square into
D
v
square.
square. Okay,
Yes, sir.
so now we will go ahead and calculate what is Fe. So Fe is half into epsilon A by d square into v square, that is going to be half into 8.854 into 10 raised to minus 12 into A has been given as how much? A is 20 centimeter square, that is 20 into centimeter is 0.01 meters, the whole square. Okay, it's not a square anyway, sorry. So 20 into 0.01 into 0.01 divided by your D is given as 5 mm, which means that so 5 into 10 power minus 3 the whole square, and V square is V is basically 5 kV, so 5 into 10 power 3 the whole square. Okay, so now you
Yes, sir.
can go ahead and solve it. You'll be getting what is Fe. So 8.854 into 20 into 0.01 into 0.01 into 10 power 6 into 10 power minus 12 into 8 into 10 power 6. So I'm getting 8.854 into 10 power minus 3.
Uh,
Any difference?
no, sir.
Okay. So this should be the force in newtons. Okay. So
Yes, sir.
once we have got what is the force, we will be seeing what is M. M is basically Fe divided by G. which is basically 8.854 into 10 power minus 3 divided by your G is 9.8 meter per second square. So that divided by 9.8 is going to give us the answer, which turns out to be um, 0.9 into 10 power minus 3. Correct?
Yes, sir.
This will be in kg. So this is the mass that is suspended. Okay. So it's actually a simple question only, just that you just need to know the basics. That is, one is of course this particular relation, that is under gravity, your mass is basically F by G. That is obvious. And the second
Yes.
one is, how do you calculate F? F is
F.
basically differential of energy with respect to the distance. Okay. And you know what
Yes.
is the energy? Okay.
Yes, sir.
Okay. So, sorry. Okay. So we will go ahead with the next problem then. I think the rest of the problems are a little simple. So the next question is question number 3. A DC shunt motor has external resistance RA and RF in the armature and field circuits respectively. Armature current at starting can be reduced by keeping dash. So the question is, how do I reduce the starting current of the motor? So we
Yes,
have
sir.
got 4 options. Keep RF maximum, RF maximum, RA minimum, then RF maximum, RA maximum, C, RF minimum, RA minimum, and D, you have RF minimum, RA maximum. So what is the correct answer?
Sir, maybe RA maximum and RF is
Correct?
minimum.
Correct. So RA maximum and RF is
And
minimum. Option D.
this is the assignment question.
Oh, okay, you got the same
Same type.
question.
Yes, sir.
Oh, okay. No worries. So
Yes.
obviously, if you want to increase the armature, I mean, if you want to decrease the starting current, what you would do is, first of all, you would increase the armature resistance because RA is in series, one,
Three.
and secondly, you would want to weaken the field in the starting, right? So
Yes,
therefore,
sir.
you would want to reduce the field current. Therefore, you would keep RF to a minimum, right?
Yes, sir.
Okay. Fine. So we will go ahead with the next problem. The fourth question is a DC shunt motor delivers rated load power at rated speed. If motor terminal voltage is reduced to half, neglect saturation and armature reaction. Okay, a DC shunt motor delivers rated load power at rated speed. Okay, so let's consider that to be omega and the terminal voltage is V. Now they have told that motor terminal voltage is being halved. Okay, then what would
Yes.
happen is the question. So I got four options over here. Option B. So speed omega m, armature current IA, and motor torque TE remain constant. B, omega m remains constant. Both IM and T are doubled. See, both omega m and T remain constant. IA is doubled. And both omega n and P are doubled. T remains constant. Okay, so what is the answer for this? So we know that for a shunt motor, right? For a shunt motor, a DC shunt motor, phi is almost constant. That is, your flux is same, right?
Yes.
And what is your speed proportional to? So let me take my pen. Okay. Yeah. So you know that your speed is proportional to V over phi, correct?
Yes, sir.
So what happens is, you see, if your flux is constant, Then if V doubles, if V increases, then obviously your speed increases. Okay. So obviously,
Yes, sir.
if your terminal voltage increases, your speed is also going to increase. Okay. So omega m increases. Omega m increases. That is one. Okay.
Yes, sir. C option may be omega m remains constant.
And I have also got one more thing, that is about your torque. Okay. So what is your torque proportional to? Torque is proportional to K into IA,
Pi by 2.
right?
Yes.
And you have got this. This is E is proportional to K into omega m. Okay.
Yes.
So, from this, what we can tell is that um, if your voltage is reduced to half, right? If your voltage is reduced to half, then your speed should also be reduced to half, but you're not having any option like that over here, right?
Yes, yes,
There
sir.
is no option of your speed getting halved over here, right?
Yes, sir.
So then
Yes,
what
sir.
we can assume is that in that scenario, so let me take my eraser. Okay. So there is no such happening over here. Therefore, you definitely know that speed cannot be doubled. Okay, speed cannot
Yes,
be
sir.
doubled. So omega m has to be constant. It
Constant.
cannot be doubled. So omega m has to remain constant. If your omega m remains constant, you know that E is proportional to K into omega m.
Omega.
Okay. So what
Yes.
happens to your K? K is going to be E is reduced by
E.
2, so E becomes by 2, and you know that omega m is remaining constant, therefore K is becoming K by 2. Correct?
K by.
K is
Yes,
actually
sir.
becoming K by 2 right now. So what we will do is we'll go ahead and substitute this in the other equation. T is proportional to K into IA. Therefore, now K is becoming K by 2 into IA. Okay?
Yes, sir.
T new is becoming K by 2 into IA new. Okay, so for the same current, what we are seeing is you are going to see twice the torque. Okay,
Yes, sir.
correct. So what you are going to see is that your torque is going to get doubled. For the same current, your torque is going to get doubled. Okay, that is one
Yes.
thing. That is one option that can happen. That is torque can be doubled. Okay, for the same current. Omega
Yes, sir.
m remains constant. Okay, and uh, now if you see that torque is getting doubled, T is proportional to IA, therefore IA is also getting doubled. Okay, this is the only
Yes.
plausible option among the four options. But actually, ideally speaking, the option should have been better. But since we don't see any other possible options, we have to go with D right now. Okay, but the option should have been better in the question.
Sir, I think maybe torque remains constant. This type of question is also included in the assignment, and in that the correct option is C. So,
That is, both omega m T remain constant and IA is
and
doubled.
is yes, sir.
Hmm. So let's
Torque.
think. If your torque has to remain okay. So if your torque is remaining constant.
Is proportional to flux and armature current. So,
Okay, so if your flux also changes, correct. Okay, so this equation over here is assuming that the flux is constant. Correct. Okay, just a second. So your E is proportional to 5 into like that, correct? And
yes.
your T is proportional to 5 into IA. Okay, so let's try to derive from these equations. Okay. So now what they have told us, E is basically becoming by 2. Okay.
Hmm.
Okay. So E2 is equal to E1 by 2. Okay. So
Yes, sir.
E2 is proportional to phi 2 into omega m2. Now E2 is becoming E1 by 2. Okay. So E2 is
Yes, sir.
becoming E1 by 2. Therefore, E1 by 2 is proportional to what? Or I can write this. Okay. So let's take the ratio between these two. Hmm. Okay. E2 by E1 is going to be 1 by 2. 1 by 2, right? So that is actually going to be phi 2 omega m2 divided by phi 1 omega m1. Okay.
Yes, sir.
Now there is no option of your speed getting halved. Therefore, what has to happen is that if your speed remains same, if omega m2 equal to omega m1, because there is no option of the speed getting halved, right? Therefore, you know that your phi 2 by phi 1 is equal to 1 by 2, correct? That is, your
Yes,
flux
sir.
is being halved. Okay. So this is
Yes.
on one case. Your flux is getting halved. And on the other case, you're having T1 proportional to phi 1 IA1, T2 is proportional to phi 2 IA2. So let's take the ratio. So T2 by T1 is equal to phi 2 by phi 1 into IA2 by IA1. So phi 2 by phi 1 is basically 1 by 2 into IA2 by IA1 is equal to T2 by T1. Okay, so if I take the normalized torque, yeah, if I take the normalized torque, T normalized is equal to IA normalized by 2, right? So,
Yes, sir.
yeah. So then in that scenario, we can tell that for the same torque, so for the for the same to achieve the same torque, what is happening is your IA is getting halved. IA is getting halved to achieve the same torque. Okay. Or in other words, to achieve new torque, to achieve to achieve the new torque, your IA has to be doubled. Only if your IA is getting doubled will your torque come to the original value. Correct? So your IA has to be doubled. Has to be doubled
Double.
to get the new torque. Yes, correct. So your option would be right. So IA has to be doubled while to achieve the same omega m and T. Correct. Yeah, but this question is kind of I would tell a question in a grayish area. So
Yes.
it's not too clear with this question. Yeah. Okay. Anyways, we will move ahead with further numerical problems. So the previous question was question number 4. So we will go ahead with question number 5. Just a second. Yeah, the field windings of a DC compound motor. So all the questions are matching with your assignment problems or what?
No, sir, not all, but this one
Couple
and the last.
questions. Oh, okay, okay, okay. So the field windings of a DC compound motor are connected in short shunt configuration. If the series and shunt field windings series and shunt field windings are interchanged by mistake, and the motor is connected to rated voltage, then dash. Okay, so you are having a DC compound motor in a short shunt configuration, right? And the series and the shunt field windings are interchanged by mistake and the motor is connected to the rated voltage. Okay, so then what would happen is a question. So option A, series winding gets overloaded. Shunt winding gets overloaded. Both winding gets overloaded. Both windings get overloaded. And neither of the two windings get overloaded. Okay, so how do we
Then
represent?
maybe because series winding has a high current, so A option, series winding will.
Yeah, so basically, so what is happening over here? That is, so what is the short standard configuration? You'll be having a series feeding something like this, correct? So you have your RS team, and then you will be having your motor, correct?
Yes.
And across the motor, you are having your RSH. This is your ideal scenario wherein you will be having your current IA flowing like this, and this is your I total. So you will apply the terminal voltage across these 2 points. Okay, and this is your ISH. So you have your motor terminal, it would have a resistance RA and so on. Okay.
Yes.
Okay. So the question is, what would happen if the terminals are getting interchanged? Okay,
Yes.
that is the series and the shunt field windings are getting interchanged by mistake. Okay,
Yes.
so normally itself, what is the current flowing through RSC? Through RSC, what is the current? Current is going to be I total, which is a summation of IA plus ISH. Okay, that is one.
Yes. Yes.
And through RSH, what is the current? RSH, the current is going to be ISH, which is directly going to be what? It is directly going to be, what is the current? V minus IT into RSC divided by RSH, correct?
Yes.
This is going to be your ISH. Okay. Now
Yes.
your RSC would be very small, correct? RSC is going to be very small. Okay.
Yes.
So I can almost write this for the sake of approximation that it's going to be V by RSH eventually, correct? It's almost going to be somewhere around this number. Okay, fine. So this is about the current rating of both of these windings. And what about the voltage rating? Your voltage rating for your shunt field winding, it is almost going to be the same as your motor terminal voltage, correct? It's going to be
Yes.
V, correct? However, the drop across your series field winding is very low. Okay. So
Yes, sir.
now the point is under normal conduction, right? Under normal conduction, when the motor is operating, should we consider the voltage or should we consider what is the current when the motor is running? So what should we consider when the motor is running? So we should be considering the current rating, correct?
Yes.
So you see that the current rating is almost the same, right?
Yes.
Current rating is almost the same, which means that even if you do interchange, none of the windings are going to get overloaded. Okay, in terms of overloading, nothing will happen. Okay, just that the values are going to be a little different and your motor speeds and all will be a little different. But the point is, motor is connected to rated voltage also, and you interchange the series and shunt field windings, nothing wrong is going to happen. Okay,
Yes.
fine. So we'll go to the next question then. So the next question is, um, okay. So calculate the voltage induced in the armature winding of a 4-pole lap wound DC machine having 728 active conductors and running at 1800 RPM. The flux per pole is 30 milliweber. Okay. So okay. So they have given it's a 4-pole machine and the lap winding you're having 728 active conductors and your speed is 1800
RPM.
rotations per minute and your flux is going to be
35 into 10 minus
30 millimeter. So since it is lap winding, you know, lap wound means obviously your A is going to be the same as number of poles, it's going to be 4. Okay. So you know that E is equal to 5 PZN
and up
over 16,
68. A.
correct? So we are going to get 0.03 into P is 4 into Z is 728 into 1800 divided by 60. So how much will you be getting? I think 400 into 4 into 728 into 1800 by 60. Okay, so sorry, 5PZN by 60 into A, obviously, correct?
A.
Yeah,
A. Yes, sir.
yeah. Okay, sorry, I forgot to do by 4, correct. So, divide. So you'll be getting 655.
0.20. 655.20.
0.2 volts, correct. Yeah.
Yes.
So 5PZN by 60A for lap wound machine, you will be eventually getting 5ZN by 60, correct. Okay. Yeah, so I think this is straightforward. So we'll go ahead with the next problem. That is question number 7. So the question is a 4-pole lap wound DC machine. 4-pole lap wound DC machine having 728 active conductors. And running at 1800 RPM. Flux per pole of again 30 milliwebers. Has an armature winding capable of carrying a maximum current of 100 amperes. Okay, so the motor specifications are the same as the previous question. They have given that the armature can carry a maximum current of 100 amperes. So, what is the maximum electromagnetic power developed by the armature? What is the maximum electromagnetic power in kilowatt? Developed by the armature. Okay, so it is the same machine, and just in the previous problem, we found out that E is going to be how much? E is 655.2 volts, correct? So E is
Yes.
given and IA max is 100 amperes. So your P is going to be what? P developed by the armature, right? So PA should be not your motor terminal voltage, rather it should be your induced voltage. That is why I'm taking E, not V. So P should be E into IA, which is 655.2 into 100, which is 65.52 kilowatt. Correct? This is the power developed by armature.
Sir, how we take the value of that E 655.2?
The last question we calculated, right? Last question was the same question. 4-pole
Yes.
lap mount DC machine, 728 active conductors, 30 milliweber
Yes.
flux, running at 1800 RPM. So in this question also it's the same thing. That's why I directly wrote.
Yes.
Or else, ideally you should calculate for every question 5Zn by 60. Correct? You will calculate what is 5Zn by 60. It turns out to be 655 point whatever
Yeah, sure.
655.2 volts. You will calculate, but for this particular question, because we calculated in the previous question, I have directly written.
Okay, sir.
Okay. Okay.
Yes.
So yeah, and since this is question is about power developed by the armature, you have to take E into IA, not P V into IA, not terminal voltage. Okay. Fine.
Mm.
So we will go ahead with the next question. Okay. So next is question number 8. So your question number 8 would be a DC machine has a 4-pole wave-wound armature. Has a 4-pole wave-wound armature with 46 slots and 16 conductors per slot. If the induced voltage in the armature oh, The induced in the voltage in the armature is 480 volts at 1200 RPM. Determine the flux per pole in milliweber. Okay.
Yes, sir.
So again, this is simple question only. So induced voltage I Zn into P by 60 into A. Correct? So
Yes,
under
sir.
wave winding, so if lap wound, then you know that P is equal to A. If it is wave wound, what is the scenario? So if it is wave wound, then what is the scenario?
Sir, we multiplied.
If it is wave wound, then P is the same as number of poles, but A will be 2. Correct?
2. Yes, means number of parallel paths we take A equals to 2.
Correct. Correct. So just have to keep this in mind, and therefore you will end up with the answer. So E is 480 volts. You don't know what is phi, and your number of conductors would be how much? Your number of conductors would be 46 slots into 16 conductors per slot. So 46 into 16,
7.
and your speed is given as 1200 RPM, and your P is basically 4 divided by 60 into A is 2. Okay, so you will get what is phi. So your phi is going to be 480 into 120 divided by 46 by 60.
16.3.
Yeah, 16.3 milliwebber. That's it. Okay. Again, a very simple problem.
So this is also the assignment question.
Oh, okay. Okay, so I will go ahead with the next problem. Then, okay, 4 pole. So it's good that you are attending this session. Probably remaining questions or some questions you may get in your final exam as well if you have registered.
Yes, sir. I have this.
4 pole
I think
lap armature.
24th April.
Yeah, a 4 pole lap wound armature has 144 slots with 2 coil sides per slot. Each coil having 2 turns. Each coil having 2 turns. If the flux per pole if the flux per pole is 20 milliweber and the armature rotates and the armature rotates at 720 RPM. What is the induced voltage. Okay, so again they have asked for E, that is what is the induced voltage. So they have given it's a 4-pole machine, which means P is 4, and then it's a lap winding, which means A is equal to P. So
P.
P is 4, lap wound, so A is equal to P. Okay. And
Yes.
now the point is there are 144 slots and 2 coil sides per slot, and there are 2 turns per coil. Okay. So which means your number of conductors is going to be how much? It would be 144 slots and
Yes.
2 coil sides per slot and then 2 turns per coil. So just a direct multiplication, correct? So
Yes, sir.
144 into 2 is 288, into 2 is 576. Got it? So there are
Yes.
144 slots, 2 coil sides per slot and 2 turns per coil. 144, 2 coil sides per slot and 2 turns per coil. Okay. And they have given that flux is basically 20.
Immediately.
Yeah, so 20 milliwebers, so 0.02 webers. Okay.
Yes.
And your N is again given as 720 RPM. Okay. So what is the induced voltage? E is basically what? 57 into P by 60 into A. So P is equal to A getting cancelled. So you will be getting 0.02 into 576 into N is 720 RPM divided by 60. Okay. So 576 into 0.02 into 720.
138.4.
Yeah, 138.24 volts. So 138.24 volts. Okay.
Yes, sir.
So we will go ahead with the next problem then. So the next question is a 100 kilowatt 230 volt shunt generator. A 100 kilowatt 230 volt. So if they just give a 230 volt shunt generator, should we take it as the induced voltage or the terminal voltage?
Terminal voltage.
Correct. As RA is equal to 0.05 ohms and RS is 57.5 ohm. If the generator operates at rated voltage, calculate the induced voltage at full load. If the generator operates at rated voltage, calculate the induced voltage at full load. Neglect brush drop. Okay. Okay, so this is operating as a shunt generator. right? So
Yes, sir.
just that your direction of current is going to be reversed. So rest of them, the principal wise, the operation is going to remain the same. Okay. Okay. So P is given as 100 kilowatt, and they have given the terminal voltage to be 230 volts.
230.
Okay. So from
Yes.
this, can we find out the load current? So what is a load current? So let's first draw the generator. So you have your V,
P by
and
V.
you have your RA, and you have your E, and you have your RSH. Okay.
Yes.
Yeah. So, or I should probably reverse the current. Okay. And you have your current like this. Let's call it IL. Okay. In that scenario, your IL is going to be how much? Your IL is going to be P by V,
P
which is 100 into 10 power 3 divided by 230. And that is going to be
434.78.
434.78
78.
amp. So this is your IL. Okay. So
Yes.
what is your ISH? ISH is going to be basically flowing this way, correct? This will be your ISH because you are applying terminal voltage over here. Okay.
Yes, sir.
So your ISH is going to be V divided by RSH. That would be your 230 divided by your RSH or RF is 57.5. Correct. So 230 divided by 57.5, you get 4 amperes. Okay.
Yes.
So what would be your IA now? What would be IA?
IL plus IF.
Correct.
Total.
IL plus,
IF.
that is going to be 434 point.
438.78.
Correct. So 438.78.
78.
Oh. Therefore, what is your EMF? EMF is going to be V
IA into RA.
plus I, correct. So V plus IARA. So V plus IARA. Just this positive sign is the difference between motor and generator. Everything else is going to remain the same. So V is 230 plus 438.78 into RA. RA is given as 0.05, right? So 0.
251.93.
Correct. So you get 251.93. Correct. So this is all same, just same generator, same operation only, just that your current direction and hence your terminal voltage or your induced voltage is going to have a positive sign. Okay.
Yes, sir.
Obviously,
Yes.
since
Yes.
it's a generator, you will see that E is going to be more than your V in a
V.
generator, right? In a motor, it's going to be the other way around. Okay. Okay.
Yes, sir.
So yeah, this is also fine, I guess. So we will go ahead with the next question. So the next question is a 50 kilowatt, 250 volt, 250 volt short shunt compound generator has the following data. So RA 0.06 ohm, RAC 0.04 ohm, and RF is 125 ohm. Calculate the induced armature voltage. Calculate the induced armature voltage at rated load and terminal voltage. At rated load and terminal voltage. Take 2 volt as the total brush contact drop. Take 2 volt as the total brush contact drop. So we have a short shunt compound generator, right? So they have given RA, RAC and RF. Calculate the induced armature voltage, right? That is E at rated load and terminal voltage. Take 2 volt as the total brush contact drop, right? Okay.
Yes, sir.
First of all, we will draw the short shunt compound generator. So you got RA and you got E over here and you got RSH. So we have got V. Okay. So
Yes, sir.
and since this is a generator, you would know that your directions of current are going to be something like this. Okay. Okay. So as usual, what is the load current? So 50 kilowatt and 250 volt. So over here you are having 250 volts and 50 kilowatt. Therefore, your load current, right? IL is going to be
PL
50
by V.
kilowatt divided by 250 volt. Correct. So P by V directly, right? So how much are you going to get? You are going to get 200 amperes. Correct?
Yes. Yes, sir.
Okay. So over here they have asked for the induced armature voltage. Okay, they have asked for the induced armature voltage, which means that you have to, uh, yeah, they have asked for the induced armature voltage. So we have to find out eventually what is EG, correct? Okay.
Yes.
Now, what is your ISH? ISH is going to be the voltage across these 2 points that I have marked in green divided by RSH. Therefore, it is going to be how much? It is going to be EG
250.
minus IARA divided by RSH. This is one relation. Or I can also write it as ISH is equal to V plus IL RSE divided by RSH. Is this correct? Just
Yes,
we
sir.
have written KVL expression. So we don't know what is EG, we don't know what is IA. So let's not use this. Let's not use this. We will use this because we know what is V, we know what is IL. Correct? So
Yes.
your ISH is going to be V is going to be 250 volts plus IL is going to be 200 into RSE has been given as 0.04 ohms. 0.04 divided by RSH is given as 125 ohms. Okay.
Yes.
So ISH is basically 200.
Yes.
You end up with 2.064 amperes. Correct?
Yes, sir.
Okay, so this is your ISH. So you know what is your ISH, you know what is IL. Now we know what is IA as well. Correct?
Yes.
So you have a current flowing out like this, you have a current flowing out like this. You want to know what is the current that is entering the terminal. Okay, that is your IA. So IA is how much? IA is going to be, sorry, IA is going to be IL
I
plus
plus
ISS. Correct. So which is going to be 202.064 amperes.
M.
Right?
Yes, sir.
So this is going to be your IA. So once you know what is IA, you are going to get your EG as well. So what would be EG? EG is going to be
IA into RA into
V.
yes.
Okay, yeah. So V plus IL RSE plus IA RA. Right?
Yes.
We have just written the KVL expression for here. Okay. So
Yes.
V is 250, sorry. So
250.
V is 250 plus IL was 200 amperes, 0.04 plus IA is 202.064 into RA is how much? RA is 0.06, right?
Yes.
So into 0.064 into 6. So you get 270.123.
178. 0038
207.
something.
Yeah, so it's somewhere around 270.
Yes, sir.
270 volts. Okay, so this is your
Yes, sir.
induced uh, voltage. So just that they have given short shunt, you should know how to draw the circuit diagram for a short shunt compound generator. So this
Yes,
is a
sir.
short shunt connection. Okay, since it's a generator, the current directions would be reversed. That's it. No other difference.
Okay, sir.
Fine.
Yes.
Okay, so we will see the last problem for the day. So this is not from motors, slightly different problem. So just a second. So the magnetic flux density on the surface of an iron phase is 1.6 Tesla. Which is a typical saturation level value for the ferromagnetic material. Find the absolute value of force density in Newton per meter square on the iron phase. Okay, just give me 2-3 minutes. I will have some water and we will continue with the answer for this question. Okay, thanks for hanging around. We will just continue with this problem. So the magnetic flux
Yes.
density on the surface of an iron phase is 1.6 Tesla, which is a typical saturation level for you for a level value for the
Venom.
ferromagnetic material. Yeah, find the absolute value of the force density on the iron phase. Okay, so was this question also asked uh, in your assignment or no?
No, sir, no. This is the new one.
Okay, okay, okay. Okay, so before we go ahead with this problem, so we have to find out what is force density, right? What is the equation for force density, correct? So
Yes, sir.
force density, it turns out, can be derived from Maxwell's equations, and you would be getting something like half into b square by mu naught or b square by 2 mu naught. But we
You
have to
know.
see how do we get to this problem, correct? So from this you will find out the answer. You know that B is basically 1.6 Tesla. So half into 1.6 into 1.6 divided by what is nu naught? Nu naught is 4 pi into
4
10 power
10 raised to
minus 7 Henry per meter. So from solving this, you'll be getting the answer, that is 1.6 into 1.6 divided by 2, right? Divided by 4.
0191 into 10 raised to power 6.
Correct. So, yeah. So 0.1 into,
1.01.
yeah. So into 10 power 7, yeah, it's the same. 1.01 into 10 power 6 um,
Yes.
Newton per meter square. They have asked in mega newtons per meter square. Therefore, you will be getting 1.01 mega newton per meter square. Directly you will be getting, that is half into b square by nu naught. We will just see how you obtain half into b square by half into b square by nu naught. Okay. Okay.
Yes, sir.
So okay. So let's take an inductor, right? So when we talk of magnetic field, we always talk about an inductor, correct? So for a coil, you know that V is equal to L into di over dt, correct? So
Yes,
what
sir.
is your instantaneous power? Instantaneous power, or if I call it as P of t, it is going to be V into I, that is L into di over dt into I, right? So this
Yes,
is
sir.
your instantaneous power. So this is your induced voltage, and this is your instantaneous power. So now we come to the actual thing that an inductor does, that is magnetic energy stored, correct? So what is
Yes.
your energy stored? So your energy stored is going to be integral PDT, right? So integral PDT, which is integral, uh, sorry. So let me add new slides. So it is going to be integral PDT, which is integral L di by dt into I, and only after you do this, you get the famous equation half L I square. Correct?
Yes. Yes.
Okay. So now you know that for a magnetic circuit, right? In a magnetic circuit, In a magnetic circuit, you know that L into I is going to be N into phi, right? L into I is
Yes.
equal to N into phi, where phi is your flux and N is the number of turns. Therefore, you end up with I is equal to what? I is equal to N phi by L, right? So you know I is equal to N phi by L. Therefore, your energy stored can be written as half into L into I is basically N phi by L. Therefore, N square phi square divided by L square. Okay. So
Yes.
you will be getting E is basically half into N square phi square divided by L. This is your energy. Okay. Fine. So far so good. Okay. Also by Ampere's law, you would know that in a closed space, integral HDL, correct, is equal to the total number of turns into the current per turn, right? Integral HDL is equal to Ni, or you know that H is equal to Ni by L. Fine, H is equal to Ni by L. Okay,
Yes, sir.
H is equal to Ni by L. And you also know that B is equal to nu into H. Okay, B is
Yes.
equal to nu into H. So, okay, so H is equal to Ni by L, and you know that B is equal to nu into H. Now the point is, so you know what is energy? That is, you know the expression for energy. What is the work done? What is the work done? Work done is going to be what? Work done is going to be your MMF, your flux, right? That is going to be your work done.
Yes,
Okay.
sir.
So your MMF is going to be what? MMF is basically Ni or HL, whatever you're comfortable with. That is from here, right? HL is equal to Ni, so MMF is H into L, and your flux is what? Phi is equal to B into A, right? Phi is basically B into A. Okay, so this is going to be your work done. This is going to be your work done or incremental work done. That is D, right? So HL into A into DB. This is going to be your incremental work done. That is HL into A into DB is going to be your incremental work done. Okay. So your energy density. So what is your density? I don't know what happened to my pen. Energy density is going to be what? You have to So your energy density is going to be incremental divided by volume, correct? That's going
Yes.
to be your density. Anything, any parameter divided by your volume. So what is your volume over here? In this expression, AL is going to be okay. So your energy
Yes.
density is basically going to be what? Your energy density is basically K into D. Right? This is your energy
Yes.
density. So your energy density, incremental energy density, therefore your actual energy density is going to be integral HdB, correct? That's going to be your actual energy density. So actual energy density is going to be integral HdB. So
HD.
yeah, so this is going to be how much? This is, so H is going to be B by nu dB, that is 1 by nu into integral B dB, where your B is going from 0 to B. So it is going to be 1 by 2 nu into B square. Correct? That is why you
Yes.
end up with B square by 2 nu. This is how you end up with energy density. Okay?
Yes, sir.
That is what we have substituted over here, that the energy density or the force density is going to be V square by 2 nu. Okay?
Yes, sir.
Yeah. So with this, we will conclude today's session.
Yes, sir.
So if there is any doubt, you can tell, or like we will meet ahead. We will meet either on Saturday or Sunday. We will let you know through the PMRF, through the
Sir,
support
on
team in
this
PTL.
Saturday?
Sorry?
On this Saturday?
Yeah,
Means
yeah.
upcoming
Either
Saturday?
Saturday or Sunday. Yeah, yeah.
Okay. Okay. Sir.
Okay.
Okay.
Okay. So we will close for the day then. Thanks for attending and good night.
Yes, sir. Thank you.
Okay.